Hello, hello, hello. So I might need to explain something. The previous slide said that we would be listening to a talk about the ancient art of belly dance. I would like to formally apologize and explain this hilarious joke of mine. In the host slides until Wednesday, very late in the evening, the title of the talk wasn't final and it just said TBD. And so Marika and I thought it would be funny to put something in, and I came up with the ancient art of belly dance because I guess something in my subconscious wanted to see Sebastian Kurfürst belly dance. And so we put that in and then told each other, Marika and I, that we would remind him that we need to replace it. And he did see it on the host slides downstairs. He didn't see it up here, and that is why we are no longer, unfortunately, going to be shown the ancient art of belly dance. Maybe you felt like the music that was just playing was a little inspired. It was. So I would like to issue a formal apology for this prank. I thought it was hilarious. Actually, I still do.
Me too.
Anyways, all that to be said, I think all of you want to know way more about event-sourced applications than belly dance, unless you don't.
Still time to leave the room?
I mean, maybe you can sway Sebastian. Sebastian, would you like to join us on stage?
Yeah, of course. Hi, everybody.
Thank you so much. I feel like this might be one of those talks where the app explodes with questions. Remember to submit them so we can answer them. And we
rate it afterwards.
And rate it afterwards. Let's say that already because we will definitely forget to say it afterwards. Thank you so much. And we'll leave you to it.
Yeah, thank you so much, everybody. Actually, that happens if you don't submit your talk title soon enough. So next time, remember. All right, 7 steps to an event-sourced application. Has anybody already written some kind of event-sourced code? A few, okay. Quite some few, nice. Okay, cool. So for everybody else, I would like to start with what do you actually need to do to build an event-sourced application. And what I'm going to do now, I've built a small example where I took the content repository, I ripped out the whole content repository, but kept the infrastructure, so to have a kind of playbook what you need to do if you want to follow this kind of architecture. And first question is, of course, why should you actually would like to do that? So sorry, there's an off by 1 error in my slides, it seems. So that means, why should you actually build something event-sourced? The way I think about problems, I usually think a lot about the way the data is structured. And if I think about that, I tend to think about state-centric problems. So that means they really focus on what is in the database, for instance, right now. And so everything which is a classical CRUD, so create, read, update, delete user interface falls into this kind of category, all this classical database kind of things, management UIs, these kind of stuff. And sometimes you have state change-centric problems, so stuff like workflows or synchronization or integration with other systems, for me, clearly fall into this state change-centric kind of problem. And event sourcing is really good in the right part of that. But there's a problem. There's not a clear distinction between the former and the latter, but it's pretty fluent, this kind of distinction. So there's a lot of gray area in the middle. And there's, unfortunately, another problem, which is that during a long project life cycle, it happens really often that you start with a state-centric approach, and then you discover that actually, over time, the state change becomes more and more and more important, right? So you start with your CRUD user interface, and sometimes your customer tells you, oh, if this happens, I would like to send something to an external system. So, this is where the state change enters the story, so to say. And it's pretty hard to change from the state-centric part to the state change-centric way of doing things if you are already deeply invested into this state-centric approach. So that's the the problem between that. So there's a very, implementation-wise, there's a very deep chasm between these two sides. All right, so we are going to focus on the state change-centric problems for now. And just for getting an idea about that, in a classical state-centric problem, so the left one, you have a database which contains all your state, and you usually overwrite the information. So that means the current state is in the database, and the problem is actually this part of overwriting or deleting information, because at this point you really lose something which you cannot easily restore, right? So some things are gone when they are overwritten. On the other side, if you focus on the state change with event sourcing, you have a so-called event log, which is a history of everything which has happened in the past, and you only append to this log. So that means it grows and grows and grows, but it contains the full history. So by definition, you can never lose history. You can never lose any information. You know all the history which has ever been done. And if you do it right, there's no way around that. So that means, yeah, it's very well scalable to future problems as well and future expectations to the system. So my goal is now to focus on how can we actually build such a system in a way that these best practices work. And I'm going to show a lot of code, but first we'll start with the basic idea. If we do event sourcing, the usual process looks like this. We start on the right side with the commands. This is the expectations we want from the system. Please update this kind of thing. Please delete a node. Create a new workflow. Change the or trigger a workflow transition from A to B. Then we have a command handler, which is the thing which actually takes this intent of the user. It checks whether the intent can be fulfilled. So this is this check of preconditions. And then it emits some events. And these events are stored in this event store. And the event store is just a fancy word of a big database table you never delete from, simply put. And then you update your read side. So these things are called projections. And by doing that, the event store becomes your source of truth, your single source of information in the system. So that means you can start to denormalize on the read side. You can have multiple read models, and that is one part of the idea how you can make this really flexible. Right, and I would like to focus on the projection side for a bit. So, yeah, what is a projection? Who knows what a function is? Yeah, thank you. Everybody not asleep yet? And that's on the second day of NEOS conference after the social event. Quite a challenge, I know. And who knows what a pure function is? Okay, also quite some people. So, actually, a projection is just a function which gets some old state in and one event, and then it has to return the new state. That's the basic idea, right? So it's basically you start from 0 and you consume the first event, and then you have to put out some new state. Then you consume the second event, have to put out some new state, and so on and so on. So that is the basic, really simple principle. It is just important that this function, projection function, is pure, so that means it needs to be deterministic. It always has to return the same things given the input, and it has to be side effect free. That means you're not allowed to read anything from your external database. You're not allowed to read from configuration. You're not allowed to write an email, to send an email. Actually, writing an email is probably something different. Right. So that means that is what a projection is. It's just a function which consumes events and puts out state on the foundational level. And now we need one more ingredient to make sense out of all that. If you look at some domains, like a workflow domain, so this is the example I've played with. It's a way to build content workflows in the system. There you have some time flowing from left to right, and so somebody creates the workflow 1, then he transitions to a certain state for this workflow. Then in the meantime, somebody else creates workflow 2. Then we create to the state B, we transition to state B for workflow 1, and then we finish workflow 2, for instance. And if you look at this, there's some kind of natural partitioning of this kind of problem domain, right? So that means these two flows are fundamentally independent of each other. The one doesn't influence the other in any way. And if that happens, we can make our projections even a bit more simple, because we don't have to put the full state of the system into this projection function, but only the state for this single partition. So for one of these flows, basically, right? Because they are independent, if they are independent, like in my workflow example. And when we have these kind of partition projections, they sometimes are also bounded in their length. So that means you will have maybe 500 or 1,000 events in this single stream of events, but you usually won't have 1 million events, right? If you do a workflow system, there's just this finite number of steps people will take, even if they take detours or anything like that. They very likely will not have this workflow running forever, going back and forth and so on. And if these event streams are bounded, then things can get a lot easier, because we can get away without persisting this new state. We can just recompute it all the time if we need it. And this sounds crazy at first, but actually it works really well up to a few hundred or 1,000 events per stream. It will not work anymore if this grows more and more and more, and if things start to get unbounded. Then we have to persist things on the read side, and I'm showing on the end, if we still have time, how this is done. All right, so I have created some package which is doing some idea of content workflow in Neos. It's actually doing very little right now. I'm showing you. So in your node types, you can configure some workflows. So this is the workflow called tech blog post, and it has some steps. Like first, we have to write an idea. Then we can go to the outline or the draft state, and then there's the review, the published, and the shared on social media state, for instance. And if we install this package and we enter some kind of blog post, then on the right side we have this button, which is not very well styled, saying Start Workflow Tech Blog Post. And if we click that, we see that we are in the idea state right now, and we can transition to one of state, basically back and forth. And so that's just the basic workflow transition idea I have implemented. Of course, in the real world, you would then add modifications to the Neos user interface depending on the workflow step you are, for instance, but I didn't have time for that before conference. All right, so that's the example I'm going to demonstrate now, and this code is all open source on GitHub, so you can have a look. All right, so that was the basic idea. Now let's look at the file structure, and if we look at this content workflow package, it's just a very normal package in Neos. But if you look closely, actually we have a classes folder and we have a source folder in here. That's my personal thing I'm trying to experiment with. The idea of that is that actually I would like to separate between the Neos-specific code and the standalone code of my system without having many packages around. But I just would like to do this conceptual separation at first. Now, that's something I'm trying out right now. And one way, a small way of doing that is, so for me personally, what I'm trying right now is that I'm using the source folder for this core business logic, which does not depend on any frameworks, and we use classes as usual for Neos specific framework code. And we only depend on the event store basically and this adapter. And actually, I already have written an adapter also for Laravel, for instance, because we needed it in a project which stores these events using the Laravel abstractions, because they don't use Doctrine internally. All right, so what we're going to do now is we look into the source folder, because we're looking at the business domain of our code. If we open it up, we have some domain area. One I'm calling workflow, and the other one is called workflow definition at the bottom, which we don't care about right now. We are focusing on this workflow part of our context. This is the structure we are using in the Neos content repository, and which we figure out which works really well. So let's see what's in there. We have a bit of infrastructure for handling commands, and we need some kind of event store. And we have this core app, core workflow app in this case, which is the one central entry point from the outside world. And then we have business logic, which we try to usually group together in features. So we have, for instance, a feature called workflow lifecycle and another feature called workflow step. And by these names, you can already guess that the lifecycle is more about the broad kind of things like starting a workflow, ending it, and workflow step is really this one thing going forward. But that usually depends a bit on your domain, and it's very likely to change that over the course of a project if you see it fitting better. All right. And then we need some kind of projection state in there, which is also business logic. It's basically the read side of our model. Okay, so that is the file structure we are going to do. And now I'm expanding the files one by one, and we'll go through that. And now the code part starts. I hope that's fine. If anything goes too quickly, try to focus on the concepts, and you can look up the code in detail later on anyways. And also ask us questions also after the conference via Slack. We are very well reachable. Okay, so we want to do event sourcing. We need an event store. And I need something to drink. So the event store is this thing which stores our events in this event log. And for us, it worked well to have a custom event store object in our project. So this is called workflow event store. You might have guessed that. And what we're actually doing is we are converting from this events we are getting from Neo's event store to the application events while reading. And we have these workflow events to persist, which we convert into the Neo's event store events. And the reason for that is that on the infrastructure side of Neo's event store, the system only really knows the bare basics. It only knows events have some kind of data, but this doesn't care about how this data is structured. So it doesn't care about whether the data is in JSON or in XML or in protobuf or in, I don't know, CSV, if you really like to do that and need a lot of pain. But our application actually cares. Our application really cares about a certain way of persisting events. So what we are actually trying to do is converting these things up and forth, and for that we have a so-called event normalizer which does this kind of conversion. So the conceptual way to think about that is that the workflow event store is the wrapper around this core Neo's event store package, and internally this uses the so-called event normalizer to convert these events. And you see normalize is the direction on the right side, and denormalize is on the reading side. And this is really just doing very basic conversion, in my case, from JSON back and forth. All right, so that is the basic idea of workflow events. So now let's look at the code, what is in there. So we need one way to write into the event store, and we need another way to read from the event store, right? So for writing, we usually call this method commit. In my case, we pass it a workflow ID, which is basically the stream we are in. We are persisting, we have a certain amount of events to persist, and we have to send in a so-called expected version. What this means in detail, I'll explain. But basically, we pass that through directly to the internal event store, and the only thing we are doing in here is enriching and normalizing the events, which is doing the conversion. So that is triggering the normalizer we have just seen. And on the other side, it's the same thing. It's loading events from the event store on the read side, and then converting the events back again in the line below to events of our business domain, and then we are returning them back. And what we get by doing that is we make sure that our events are a COSM or are not interchangeable with any other event-sourced applications in other packages, for instance. So it's really one world of our own, which is what we want, right? We don't want one global event stream where we put everything in somehow randomly, but we want, basically the event sourcing is a specific concept for this single package. So that it's inside the bounded context and not just a global thing. That was also something we realized back then, because when we started building this event source stuff, we are more thinking about this, oh, you have one event store and put everything in there, but it turns out to not really be practical on the long run. All right, so we have a way to store and read events now and can convert them. Very good. What else do we need to do? We need one way to handle the write side. So if something has to change on my system, we need to dispatch commands to the system. And what we do here usually is have a command handler, infrastructure stuff, and there the command, let's see what this is. So the command interface is on the very top. It's just a marker interface to say, okay, this is a command. These kind of things which implemented is a command. The command handler interface has two things to do. It has one way of telling the system, I am responsible for a certain kind of command. And the second is actually handling that command, which means changing the state, checking preconditions, and it returns the events which need to be persisted to the database. And it's usually you need some way of accessing the read side of the system, and this example, I'm passing it right in. I could also pull it out from another object if needed there. This is for checking constraints. We'll get to that in a bit. All right. And now the last infrastructure part I need to explain is this core application, this core workflow application. This consists of a lot of initialization. So that means in the constructor, we have to register which events the system knows. So that's the first part, which is basically telling the system which events we are able to convert. We need to instantiate our event store, and we need to instantiate our command handling system. So this command bus on the bottom, and we put in the different command handlers there, which exist in the system. And then we need some way of reading from our core application. So that might be a method to get a projection, or I call this in this case state for something. And so what we do now here is we access the event store, get all the events, and then from these events we build up the current state. Because remember, what we are doing is we are recomputing the current state just as we need it. We don't store it in the database at this point in time. Okay, so this is the reading side, and now we get back to the writing side of the system. This is actually the most tricky code I'm gonna show. So because this kind of system is always working in this separated bounded context, in the separated streams, I'm passing in a workflow ID here, and the command I would like to do. And what this thing is doing is it's reading the state from the system at the start. So this is reading the current state of the system. Then we run the current command handler. We get back the new events which should be published, or it throws an exception if things go wrong and preconditions are not fulfilled. And then we are persisting events to the event store. And the important part is this comment here, if nothing changed in between in this stream. So that means we want to do some kind of consistency checking, saying we want to make sure that what we read here is the thing we can make decisions here and was not modified in the meantime by somebody concurrently. So this is what this code is doing. Don't worry about too much if you don't understand all the details in here, because if you normally program today with an ORM, like Doctrine ORM, actually you don't have any of that usually. It's just luck usually if there's a conflict or not. So of course you can handle that with Doctrine, but in most projects I have seen and also have developed, developers and also myself usually don't care about that because it's just hidden away from you and you have to actively think about that. And by this infrastructure actually we get a lot of consistency in my system, way more than with the average, I don't know, ORM-based version. Okay, so now we are able, just recap, we have the infrastructure ready, we have a core class which we can read the state from, we can write write new commands, and these commands get converted to events, and this is again persistent. So that, if you remember this first cycle at the start, we are having the pieces pretty much ready. There's one thing left now, which is the read side, which is the projections. And it's actually, it depends very much on the project, how this should be structured and how this makes sense. So in my case, I have implemented my projection state as a class which is composed by some traits to have these different concerns of the projection separated. But that's really very, very individual, but that's a very pragmatic first start into this whole world. In NEOS, we'll do it a little bit differently because we have different parts of projections which function fundamentally different. And in my case, we initialize the state with a set of workflow events, and then for instance, to access the node ID of the current workflow, because my workflows are always tied to a certain NEOS node, so you start them in the context of a NEOS node, so you need a way to retrieve this NEOS node back. We have an accessor which says, which then goes through all the events and finds the first event of type workflow was started, and then we know that this event has a certain property, which is the node, and this is the node ID we would like to return. So basically, we always work with this stream of events, and we search for that forth and back by filtering and so on. And you can actually get really, really far if your domain is bounded. All right. That was a lot of boilerplate now. But you only have to do that once. You can usually copy-paste that from some projects like this one. And as soon as you started doing that, implementing a feature is always boiling down to the same step of things to do. So first, we have to build up a command, or we have to create a command class. We have to do create a command handler, which tests preconditions. And for that, it might fetch state, fetch projections, or it might load configuration. So that means the command handler can do all the side effects, which you're not allowed to do on the projection side. And then the command handler returns the events, so we have to create the events. So that means, let's see how we can implement something like transitioning to a certain step. So that is the operation I would like to do now. I'm at a certain workflow point, and I want to do one step to the next one when the user clicks a button. So for that, we have a command which we have to create. You see that on the right side implemented. It just consists of the information you need to do this step. So you basically just say, what is the next step I would like to transition to? Then you need some kind of command handling adjusted. I'll show that in a second. Then we need an event, which pretty much will look like this, because it needs to contain the same information, but it might also contain some more information, as we will see. And then we have some state, which we also need to modify, which is the way to access it on the read side. And we can actually, for every feature we are doing, we can do these steps, and this scales very, very well, although it's a bit of typing, especially in the beginning. Okay, so we created the command. Then we need to do the command handling. And so if we already have a command handler, we have to modify both the can handle and the handle method, in the sense that can handle also has to check for this new command we just created. In this handle logic for the command handling, we usually have a big if-else statement, so this fancy match statement saying, okay, if there's a command coming in which is a transition to step, then please call handle transition to step. And in here, we can actually, we can read things, like here we read things from the state, for instance. We can throw errors if things go wrong. And if everything goes right, we can return our events from that. So we convert from commands to events at this point. And the event contains a bit more information than the command because it also contains the information about which step was completed, right? So my command only contained my target, so this is the thing the user clicked on. But in the event, it's very valuable to also know where you are coming from. So this is what the command handler has added to the system, and that's something very typical to see. And because the event needs to be persistent in the event store, we need some way to save it and read it. So we need a way to convert it to a string and back. And I usually have a JSON serialize function and make it implement JSON serializable, and have an extra function called from array, which does the reverse direction. And we actually, I'm usually programming that out, although it's a bit repetitive, but it's just very easy to debug if things go wrong. Okay, and the last thing we need to do, we need to create a new step, adjust our projection side. So we can do things like, to figure out the current step, we don't only look at the workflow was started event, but also we need to check the transition to step event so that we can return the current step we are in. Okay. Now, this is all nice if you can work in these single streams, what I explained in the beginning, right? So if you have one workflow and a second workflow and they don't interfere in any way. In practice, it turns out this might work for 80% of your problems, but not for the last 20%. It doesn't work if your domain is extremely complex, and sadly, it also doesn't work if you want to have some global position in your user interface to, for instance, show what workflows are open, you know, because at this point you need the global information, at least, like what is the currently running workflow. You need some kind of list to look into that. And that's something, that is a part, actually I'm quite more quick than I thought. This is a part which is a bit tricky to get right. So what Bastian Weidlich has done is create a package which is called the subscription engine, which handles this catch-up side on the projections for you and making sure that you get an event only one time, really exactly. That's basically the way how we do it in Neos. And what you need to do for that is you need to create some, you need to instantiate a subscription engine in your core application, and you need to pass it some information like which table we need to use to store, how far we are in the stream. And we need a setup method which is able to boot the system up and create the necessary entries in the table. And then in the handle method, so when we persisted an event, we then have to catch up our subscription. And this will then understand that we already have 3 events in the database, in the event store, but we only saw the first event at this point. So that means event 2 and 3 will be executed, and our projection can then be updated. So that's a part which has been created just last week. So that's pretty new in the standalone version, but we are quite happy with the current solution right now already. And it's things which you can easily pull into your project. Okay, so to wrap it up, all the example code is on GitHub in Sandstorm Content Workflow repository. So actually the package is not doing anything besides these few buttons you have seen. So the actual workflow part, which brings value to users, is not in there yet. And what we've seen now is that we need some kind of infrastructure layer with the event store and the command dispatching and this core application, which is the main API. And then we have the read side with either the simple in-memory projections, and the other way would be persistent projections, where we have created a subscription engine you can pull in and use for creating persistent projections. And last but not least, we have to write command handlers for the right side of the system. So that's basically it. And I'm happy to be there for some questions.
Well, very good. Thank you, Sebastian. And also you, as a speaker, got some presents.
Thank you.
And we do have some questions. I saw two before I stepped up the stage. It might have become more, not yet, but oh yeah, they come dropping in. So please keep on. So first one, what happens when the event log table gets, quotes, full? Mm-hmm. Can a website get slow because of a huge event log table?
Yeah. So we have never experienced that. That's the short answer. But the thing is, the event log is only relevant in the most written to and read parts, so the rightmost part, basically. So the newest part is the thing which is constantly appended to and also read from. And databases are generally extremely efficient at these kind of access patterns. That's the one part of the story. And the second thing, if it ever gets slow, it's extremely easy to take the first 1 million events and put it somewhere else and put them to persistent storage, for instance. And if you need them at any time in the future, you can just pull them out, because it's very easy to write this kind of adapter if you would need that at this point in time.
Cool. That's an interesting question. How would you handle anonymizing data after some time, e.g. for regulatory reasons?
Yeah, that's a good question. There would be two options there, I think. The one would be to move the data, this GPTR data outside the event store in a way which is only where you actually leave the event store part of the system. So you would only have an ID in your event log pointing to this data, and then you could override it and delete it basically and saying, okay, this is now gone, right? That is a valid version. Another one would be to encrypt this data and store the encryption key for this user in an extra table. And if you want to anonymize the user, you just delete the encryption key, and this way it's not possible anymore to read this data. Of course, please use safe encryption for that. Don't program it yourself. Use the standardized stuff in the PHP library for that.
Yeah, perfect. Got a very similar question. I guess this has been answered by this one. What if I want to lose information? I think that has been answered. Which approach would I use to expose different states of my content to the user?
Sorry?
Which approach would I use to expose different states of my content to the user?
So you mean different, I guess it means different points in time, in history, I would say.
Probably.
Yeah, okay. That is basically event sourcing, and this pattern doesn't say anything about that. So it's basically up to the projection to do that in some way. So that means we don't have a really good solution to that yet. But you could imagine some kind of snapshots, for instance. That would be one option. Or another way would be what Michael has shown yesterday with this Neo4j adapter at the stage below. There, the database can provide us this information. But if you only have these different streams of events which you have seen, you actually already have that, because you have all the stream of events and you're free to read that just up to a certain point, and this way you can easily traverse in history because you never persist this state. So it's easy to just read it to the half of it. So if that works for you, that's also an option. Yeah.
Mm-hmm. The last one is quite similar to what we already had, but maybe a tad different. In Git for content thinking, can I flatten all events belonging to a node at some point to reduce events?
Yeah. So I mean, this is really, what I've shown is basically applicable to any kind of state change centric problem, right? So, and the important thing is to first think about the event log as some immutable thing which is only appended to. So you never delete or remove or modify conceptually. As usual, there are exceptions to this rule, and it is totally valid to compact events to a certain point in time, and actually we already experimented or tried this in Neos as well. It's not active right now, I think, but we experimented, for instance, with something. If you type and you have lots of editing events for one node, this could actually get compacted when you publish it to one single event then. So it is certainly possible to do that, and it's also valid to do that. It's just important that you really take care or make sure that you don't break the promises of the system. So that means the compression actually needs to create the same result as the initial event. So that's your job then. Yeah.
Okay. Well, that was it for the questions. Thank you so much, Sebastian, for these terrific insights into event sourcing in this case. Perfect. Thanks a lot.
Thank you.
Your applause. Well, that was the last talk for the conference on this stage. I wanted to have, before ending it off here, personal thanks to all the audience. Maybe Maya, would you join me on stage shortly?
Hello, sorry. Hi.
I just wanted to say goodbye, and to thank you for.
No, thank you. I would
being on
not.
stage
I would
with
not
me.
enter the stage without you. You're my safety. Then again, I just said to to Sebastian too, that you guys are the safety too. I don't think I would feel as comfortable as I do in front of a different crowd.
Yeah. Thank you for being such a great audience. Thank you.